Hey, in this video, we'll talk about how to find limits involving trig functions like sine, cosine, tangent, cotangent. Okay, um, so let me remind you about one important limits. Let's limit sine of x over x when x goes to 0. That is equal to 1, right? So of course, you can write actually from here we have limit of x over sine of x also equal to 1 when x goes to 0, right? Uh, and sometimes if you have limits and you see sine x over x, so we can separate them and then we make them 1. But in this video, I want to emphasize another meaning of this limit. I want to talk about similarity. Similarity. What does it mean? So since we consider limit of two functions sine over x, and that is equal to 1 when x goes to 0, that means when x is very close to 0, these two functions are almost similar. Make sense? Are almost similar because the limit of their quotient is equal to 1. So I say when x is very close to 0, sine of x is similar to x. Is similar to x. What does it mean? That means when you consider the limit or when you consider those functions, you can replace sine of x with the x or x with sine of x because they are very similar. They are almost the same. That is very important ideas in mathematics. Sometimes we need to, of course, in the textbook, you don't see that idea. In the textbook, they describe how to use this limit and other properties of limits to solve limits involving trig functions, right? But if we use this idea, it's almost equivalent form of that limit. Limit equal to 1 means they are similar. Okay, let me show you one example how to use that idea to solve limits, right? Let's say you consider the limit of sine of 2x over x, right? It's pretty easy. When x goes to 0. When x goes to 0, sine of 2x is also going to 0. So that means you can use similarity, this similarity for sine of 2x. So in here, you have sine of 2x is similar to 2x, right? And then that's why the limit of this guy is just equal to 2x over x when x goes to 0, which is 2. Done. All right, it's easy. This is an easy example. Let's consider more complicated one. More complicated one. So I say limit of sine of 2019. Let's say that, right? X minus x over x. How about let's do that over x when x goes to 0. Or maybe you can make it more complicated. For example, sine of x. Okay, so usually you can use, for example, you separate this term with this term, this term with this term, right? You get sine 2019 over this and x over this. Let's make that. So I use similarity at 0. Sine of x is similar to x. I will replace sine of x with the x. Sine of x with the x. I have this limit equal to limit of x to 2019 minus x over x when x goes to 0. How about that? It's easy, right? So then you factor x on the top and you get this limit of x to x to 2018 minus 1 over x when x goes to 0. Then you simplify x and you plug 0 into this function, you get -1. You see, that's how similarity works. Okay, I need to mention that this similarity works only around 0 when x approaches 0. When x approaches another point, we don't have that similarity. Don't forget about that. Okay, in the textbook, you will see another famous limit. Another famous limit. That is limit of cosine of x minus 1 over x when x goes to 0 equal to 0. I want to use similarity to prove that. Okay. So how to see that? We know cosine of x. Now we use double angle formula. Cosine of x is equal to 1 minus 2 sine square of x over 2. So this is double angle formula. Usually you have cosine of 2x equal to 1 minus 2 sine square of x, right? But instead of 2x, if you have x in here, so here should be a half of this angle. So that means here should be x over 2. Now you see, if we use similarity, sine of x similar to x, s0, right? S0. Sine of x squared over x over 2 is similar to x over 2 squared. So I said this is similar to 1 minus 2x over 2 squared, right? Because instead of sine of x over 2, I have x over 2 and then x squared, right? And this is nothing but 1 minus x squared over 2. Because x squared over 4 and 4 with 2, you simplify, you get 2 here. So what does it mean? That means cosine of x is similar to 1 minus x squared over 2 at 0. Right? Let me rewrite it. Cosine of x is similar to this. Cosine of x is similar to this, right? Then from here, you subtract 1 from both sides. You get cosine of x minus 1 similar to negative x squared over 2. And if you divide both sides by x, and then you turn x to 0, you get from here cosine of x minus 1 over x similar to negative x squared over 2x, which is negative x over 2. And of course, that function negative x over 2 has limit equal to 0 at 0. Right? It's easy. And then we might have another similarity for tangent at 0. This following. So I have these two graph similarity, right? This I write cosine of x is similar to 1 minus x squared over 2. That means if you have limit with sine, cosine, you can use those things. You can replace sine with x, cosine with 1 minus x squared over 2. Okay? So how about tangent? Let's say tangent of x, that is sine of x over cosine of x. Okay? So if we consider limit of tangent at 0, I have the following one. I have tangent over x from here, tangent over x, tangent x over x equal to sine of x over x cosine of x, over x cosine of x. And then, since we are considering at 0, so sine of x is similar to x. So this guy is just similar, I write at 0 to x over x cosine of x, right? And so you simplify this x and x, you get 1 over cosine of x. And now you have limit of tangent of x over x when x goes to 0. That is just limit of 1 over cosine of x when x goes to 0, which is 1 over cosine of 0, and that is 1. So what does it mean? That means at 0, tangent of x and x are very similar. Okay? So I have tangent of x similar to x. You see? So let's take one example from the textbook, and we'll see how those things can be applied, right? Can be applied. So for example, I need to consider the following function, the following limit of x, limit when x goes to 0, and then um, just say sine of x squared over x, right? It's a simple one. So again, at x, when x approaches 0, sine of x squared similar to x squared. So I write here sine of x squared similar to x squared. That means this limit is equal to limit of x squared over x when x goes to 0, which is limit of x when x goes to 0, which is 0. So it's simple. What else? We can see, for example, cosine. Limit of cosine of x tangent of x, right? Tangent of, let's say, cosine of 5x, tangent of 3x over x when x goes to 0. Okay, when x goes to 0. So cosine 5x tangent 3x when x goes to 0. They have different angles in here, 5x, 3x. But I still can use this similarity. Tangent x is similar to x, so this tangent 3x at 0 is similar to 3x, right? So this limit, I write here, tangent of 3x is similar to 3x. So this is limit of cosine of 5x, 3x over x when x goes to 0. And you simplify x with this guy, you have 3 cosine 5x, and you plug 0 into this function, you get 3 cosine of 0, which is 3. Yeah, that's how we can use similarity when we consider limit with trig functions at 0. When we study limit of fractional functions, and when x goes to infinity, we have another kind of similarity, but similarity at infinity. Okay, so this topic is interesting in the sense that if you don't pay attention on this, right? So sometimes we might have difficulty in solving such limit. So I hope that this video is useful for you and helpful too. If you like it, just subscribe, okay?